Another type of theoretical system were theoretical VCRS system with undercooling. Very important, undercooling. So actually the previous case was having superheating. So this is superheating, and now we are moving to study a particular system called where there is undercooling. So this is TS diagram. So starting from 1 to 2 to 2 dash 2 dash 2, and here is where undercooling takes place. So actually it is coming to 3 dash, and it is again cooled along the saturated liquid line to 3, and from 3 expansion takes place to 4, and 4 to 1. So this is called 3 dash to 3 is undercooling. So this is a TS diagram. Okay, the same thing can be shown in a pH diagram. So you know the pH diagram, pressure enthalpy diagram, it will be like this. So 1 to 2 will be like this, 2 to 2 dash will be like this, 2 dash to 3 will be like this. So since this is a cooling, undercooling is a cooling process only, so cooling process takes place in constant pressure. So 3 to 3 dash will be like this. From 3 dash to 4 takes place, expansion takes place. So this is the process shown in pH diagram. Okay, so this will be a straight line, this will be a constant pressure line. So this two, here heating and cooling will be taking place in constant pressure line. So this is a system where undercooling takes place, and we will do a very small problem based on this undercooling, and we will find out what will be the advantage of having an undercooling. So before that, how to write the COP? COP is equal to refracting effect RE by work. So here refracting effect is H1 minus H4, right? H1 minus H4, and work will be H1 minus H2 itself. So H1 minus H2. So here actually H4 is equal to H3, right? So H3 is not equal to H3 dash. Okay. So you cannot directly find H3 from the H3 dash, HF3 dash. So or HF3 dash. Earlier and all we could easily find out H4 from HF3 dash. But here H4 is not equal to HF3 dash. So what will you do? So you will apply an equation, or you will add. So HF3, H4 will be equal to H3, H3 will be equal to HF3, but it won't be equal to HF3 dash. You cannot directly find HF3 because you don't know the temperature. T3 is unknown. But T3 dash may be known because that is condenser temperature. You may be, sometimes it may be given. So what will you do? So you will H4 is equal to HF3, and HF3 will be equal to HF3 dash minus Cp into degree of undercooling. Degree of undercooling. Similar, in case of superheat, we found out, like we used the equation H2 dash. So H2 equal to H2 dash plus Cp into degree of superheat. But here HF3 equal to HF3 dash minus Cp into degree of supercooling. So this will be HF3 dash minus Cp into T3 minus T3 dash. Okay. So this equation you have to be thorough. Okay. Now we will do a problem. So a vapor compression refrigerator uses R12 as a refrigerant, and the liquid evaporates in the evaporator at minus 15 degrees Celsius. The temperature of this refrigerant at the delivery from the compressor is 15 degrees Celsius. When the vapor is condensed at a 10 degrees Celsius, the coefficient of performance, if there is no undercooling and if the liquid is cooled by 5 degrees Celsius before expansion. So 2 COP we have to find out without undercooling and with undercooling. So how to find out? So students, here the take specific heat at constant pressure for superheated vapor is 0.64 kilojoule, and that for liquid as 0.94. Other properties are directly given in the question, so you don't need to obtain those values from the reference table. Already the values are given. Now you have to draw the TS diagram. How to draw the TS diagram? Uh, so this will be TS diagram. So first we will draw without undercooling. So since in the question it is given that the temperature of the refrigerant at the delivery from here the liquid evaporates in the evaporator at minus 15 degrees Celsius. So this particular temperature is minus 15 degrees Celsius. Okay, and that is the temperature of the refrigerant, the delivery from the compressor is 15 degrees Celsius. So the compressor this is 15 degrees Celsius compressor delivery. One more temperature is there when the vapor is condensed at 10 degrees Celsius. So condenser temperature is 10 degrees Celsius. Compressor temperature is different from condenser temperature, so so it will be definitely a superheated. There will be a this is 2, this is 2 dash. Okay, so students, you won't be able to fix the value, fix the position of one, whether it is here or whether it is inside or whether it is outside. You won't be able to know because it is not given that simple saturated cycle. Here it is not particularly given in the question that this is a simple saturated cycle. If it is given that simple saturated cycle or the entry at the compressor is completely saturated vapor, such things are not given, so you cannot ensure that one is here on the line or inside the line or outside the line. So that's a big problem. So how will you do this problem? So that is a very important problem. So here you have to apply a trick. So what is that trick? Because S2 will be equal to S1, because 1 to 2 is isentropic only, isentropic. So S2 will be always equal to S1. But if you can find S2 as S2 dash plus Cp log T2 by T2 dash, right? So S2 dash is nothing but from here itself, S2 dash is corresponding to 10 degrees Celsius. So this is S2 dash. So corresponding to 10 degree specific entropy of vapor is 0.6921, right? 0.6921 plus Cp will be, for saturated vapor Cp should be taken as 0.64, right? 0.64. So that is also the 0.64 log T2 is 15 degrees Celsius, 288. So you should take it in Kelvin itself because we are dividing. We are taking the ratio. So it will be in SI. It should be in SI unit itself. T2 dash is 283 Kelvin. 10 degrees Celsius. So you will get S2 as 0.7034 kilojoule per kilogram Kelvin. Okay, and S1 should be equal to S2. Therefore, S1 is also equal to 0.7034. But students, if one was on this particular one was on this particular line or saturated vapor line, then S1 will be equal to Sg, right? Sg at corresponding to -15 degrees Celsius. So Sg corresponding to -15 degrees Celsius is 0.7051. 0.7051. But St is equal to St at -15 degrees Celsius is 0.7051, and St is greater than, so this value is greater than this value, right? So St at -15 degrees Celsius is greater than S1. So naturally position 1 should be inside the dome, right? So Sg, so this value is greater than S1 means S1 should be inside the dome. So that is the trick, because this is 0.70, how much? 0.7034, 0.7034, and this is 0.70 some 52, right? 17051 or 52. So the position of 1 will be inside the dome. So you have to redraw this figure. So this will be like, so 1 will be here, 2 will be here, 2 dash will be here, this is 3, 4. Okay, so this temperature is 15 degrees Celsius, this is 10 degrees Celsius, this is -15 degrees Celsius. T, yes. Okay, so this is the figure for the cycle without undercooling. And now you got the entropy here. Now how to find H1 you will be able to find, because since it is inside the dome you have to apply the dryness fraction X1. Okay, so H1 will be equal to to find H1 will be equal to Hf1 plus x1 into Hfg1. So Hf1 will be the value corresponding to this value. This is Hf1. So Hf1 can be obtained from corresponding to, so this is 22.3, and Hfg1 will be the difference of vapor. This is Hg, this is Hf. So Hfg1 will be Hg minus Hf, 180.88. So this is 22.3 plus x1 into 180.88 minus 22.3. But we don't know the value of x1. x1 equal to unknown. So how to find x1? You can get the value of x1 from S1. So how? S1 is equal to actually SF1 plus x1 into SFG1. So SF1 is nothing but this value. SFG1 will be the difference of this and this. Okay. So SF1, see, 0.7, 0.7034 will be 0.7034 is equal to SF1 will be 0.0904 plus x1 into 0.7051 minus 0.0904. So you will get, solving this equation, you will get x1 Reynolds fraction at the point 1 will be equal to 0.997. So apply this x1 in this particular equation. Okay, so here x1 is equal to 0.997. so substituting this value here, you will get the value of h1 as, h1 will be obtained as how much? H1 will be around 180.4 kilojoule per kilogram. So we'll get the value of H1. And now substituting this H1 for COP. So COP equal to H1 minus H4 by H2 minus H1, right? So H1 minus H4 by H2 minus H1. So H1 is 180.4 minus H4 will be HF3. So HF3 by H2 is unknown and H1 is 180.4. So what is HF3? HF3 will be equal to H4 will be equal to HF3 equal to H3 corresponding to minus 15, corresponding to 10 degrees Celsius. So this is HF3, right? So this will be corresponding to 10 degrees Celsius. HF corresponding to 10 degrees Celsius will be HF3. So HF3 will be equal to 190. So what was the value? Okay, this is HF3. Okay, this is HG. So HF is this one. So I will clear it out. Okay, and this value will be HF. So this is HF, this is HG. HF corresponding to 10 degrees Celsius will be 45. 45.4. And now we don't know H2, but H2 is nothing but H2 dash plus Cp into degree of superheat, Cp into T2 minus T2 dash. So H2 dash is how much? H2 dash is corresponding. So what will be H2 dash? H2 dash will be this one, 191.76. 191.76 plus Cp should be taken as, Cp of the superheated will be 0.64. 0.64 into T2 is 288 minus this will be 5. Degree of superheat is 5. So you will get H2 equal to 194. You will get 195, around 195. So substituting this equation in COP, so COP will be equal to 180.4 minus 45.4 minus divided by 195 minus 180.4 will be around 9.27. So without undercooling, COP will be 9.27. Now we have to find the COP in case of undercooling. So this is 1, so this is 2 dash, and this is 3 dash, and this is 3, and this is 4, and 4 to 1. Okay, now this is with the undercooling. So this temperature is, these temperatures are known. This is 15 degrees Celsius, this is 10 degrees Celsius, this is minus 15 degrees Celsius, and this temperature T3 is also known. How? Because it is given that a liquid is cooled by 5 degrees Celsius. So the degree of undercooling is 5. So this difference will be 5. 10 minus 5 will be again 5 degrees Celsius. 5 degrees Celsius. Okay. And how to find? So all this COP here is found out using COP here is H1 minus HF3 dash by, instead of HF3, actually you take it as H for itself, H2 minus H1. So these all these three values are same, but here H4 is not equal to HF3. H4 equal to HF3 dash. Okay. So students, HF3 dash equal to HF3 minus Cp of liquid into degree of undercooling, that is 5. Degree of undercooling is 5. So HF3 is already not 45.4 minus Cp of liquid. So Cp of liquid is not same as that of Cp of superheated vapor. Cp of liquid is 0.94 given. The liquid is 0.94. So 0.94 into 5. So it will be around 40.7 kilojoule per kilogram. So substitute this value in here. So here you will get COP here. It will be H1 is 180.4. H4 is here now 40.7. And H2 is 195 minus 180.4. So here its value will be 9.59 with undercooling. Okay, so without undercooling it was 9.27, and with undercooling it increased to 9.59. So students, so undercooling and increases COP get increased. Undercooling will increase the COP. Similarly, superheating also increases COP. Okay. So with this we will stop this session. Thank you.